So this experiment under simple harmonic motion, it can come in different form. What you just understand, what you just need is to understand the diagram. And I told you in our previous video that there is no physics practical that they will not give you diagram. So you look at the diagram, you use the diagram to set up your experiment. So simple harmonic motion experiment can come in different form. Let's start from the simplest one and the most common one. So like this one now, you can have it like this. That will be asking you to change the length of this thread. So the most important thing under this one, it must be displayed at very what? Very small angle. You do like this. Display is small. Then release it. And the common mistake the one they make under this one, under simple harmonic motion, is that to them we believe as if immediately they release this one, they have to count the number of oscillations. It's not like that. I can just display it like this.
I may not start time immediately.
I will start at my convenient time. But another thing is this. If you start here now, so this is just one. Why some students will just say, well, immediately they start from this point like this, they will say one. No, it has not gone and come back. You allow it to go and come back to make a complete oscillation before you say one. Like if I start now, one. That's all about this one. Then if you want to tie it here, you have to be very careful. Use something like this so that if you want to adjust the length, you just draw this one, loose it here small, then draw this one to the next length. That's all. Then you tie it back. Very simple. Otherwise, you will not know when this one goes. We'll be removing and the length will be increasing. Now that's that about this one. Now another type is this form. This can come in this form as well. So where you'll be adding what? We're adding the masses. This one as it is with the anger is 50 gram. Place this one. That's all. So mostly this one is something like 10 oscillation. Just display it slightly down like this, then release it. You can't at least 10. I think mostly it's 10. But this one is always for 20. Now you had another mass. So then you record the amount of the mass. This is 100 now. Then display small. So you see that as you are adding the mass, the period of oscillation will be increasing. So after counting 10 or 20 oscillation, so you had another one. Then you do the same thing. Slide slightly. That's all. And make sure it's performing to and fro. To and fro. That is oscillatory motion. Then it can also come in this form. Now you have it like this. This one. So you have it like this. Sometimes they may ask you to start with 50 gram. Place at the specific position here. So when you place it there, then you display this one 10. Then you count. Then you add another one. Sometimes they may ask you to be varying the length of this. Place it here. Then display it and count. Then adjust it. Display it and count. Adjust it. Display it and count. While in some cases, they will just ask you to place this one at a fixed position while the number of masses will be increasing. When it is 10 gram, you display it and you count it. When it is 100 gram, you display and you count. So just discover that as you are increasing for this one, as you are increasing the amount of mass on it, the period of oscillation also will be increasing. This is another one. So in this case, we are going to use 2 spiral spring, and very easy. The only problem of this one is that you must measure the length of this one. Make sure you have the equal length. Then use spiral spring of the same length. Then this thread also must be of the same length, such that the distance from here to here and distance from here to here will be equal. Then we will now ask you to place the mass at the center. Then take note, the distance from here to here and distance from here to here must be equal. Otherwise, it will not give the correct oscillation. So now place like this. When it is 50 gram, then display it slightly. Then you count the number of oscillations given from the question. Then after that, he asks you to add more mass, then display it slightly. You now discover that as you are adding mass, the period of oscillation will be increasing. So look at it, display it. So it is in line with the formula for finding what? Period of oscillation, which says T is equal to 2 pi square root of m over k. Likewise, that one, under that one too, the one you are going to be changing the length, that one too is from T is equal to 2 pi square root of L over G. So the higher the length, the higher the period of oscillation. So the same thing with this way. The higher the mass, the higher the what? The period. That's all. So just is what you are going to have a straight line graph. So that's just the summary of different form of simple harmonic motion graph.